Hello and welcome to some more essential knowledge for mathematical methods. This one's going to be on fractions, and we're going to be covering sort of three main points. So first off, we're going to be thinking about equivalent fractions. Then we're going to be thinking about adding and subtracting fractions, and then obviously multiplying and dividing fractions. Okay, so that's our schedule for this video. Before we start, I want to just make the statement that in maths methods, improper fractions are good. Fractions are your friend. And a second statement as well, fractions are better than decimals. Okay, so there's a couple of outrageous statements. The second one's probably the most outrageous for you, that fractions are better than decimals. So if you have the option of putting your answer in either a fraction or a decimal form, choose fraction. Okay, and the top one, improper fractions are your friends. That's similar to the second one, really. Instead of writing 1.5, you write 3/2. Okay, that is much better. It's neater, and I guess the reason behind it is that fractions sort of show accuracy. Okay, if you've got 1.5, no one's really sure if it was definitely 1.5 or was it 1.49 and you decided to round it to 1.5. Did that happen? Maybe. But with 3 on 2, people are 100% sure that it's completely accurate. Okay, so it's an issue of accuracy. And the other reason is that soon, after you've had a little bit of practice, you're going to realize that improper fractions and fractions in general are actually much easier to manipulate than decimals are. Okay, so fractions are also easier in the long run. Okay, they're easier in the long run. Alright, let's get started with some equivalent fractions. So, point 1, equivalent fractions. And this was partially covered in the last video. So equivalent fractions are all about multiplying by 1. So multiplying by 1, but writing 1 in a clever way. Okay, here's what I mean. Let's start with the fraction 9 on 2. Okay, it's an improper fraction, 9 on 2. We want to find some equivalent fractions to that. So we're going to multiply it by 1, but we're actually going to write 1 in a clever way. We're going to write it by, like 2 on 2. Okay, so now this becomes, well, 9 times 2 is 18, 2 times 2 is 4. Okay, so this is now an equivalent fraction. 18 on 4 is the same fraction as 9 on 2, written in a different way. Okay, so you can, of course, go backwards. That's the real power of this, is going backwards, because you know that 18 on 4, you factorize both of them. So 18, you know, is 2 times 9. 4 is 2 times 2. So you've got a 2 over a 2, which equals 1, so you can cancel those out and get 9 on 2. Let's do another example of simplifying. Okay, so this is simplifying. So simplifying fractions here is the same thing as doing equivalent fractions. So you might have, let's see, you might have 32 over 4. So with 32 over 4, you know that 32 can be written as 4 times 8, and 4 is, of course, just 4. So the 4 and the 4 cancel, they're 1, and we get 8. So in this case, simplifying this fraction was the same thing as evaluating it, and you got 8. So that's also the same as 32 divided by 4. Let's do another example. 27 divided by 81. Okay, so if we factorize both, we know that 27 is 3 times 9. 81 is 9 times 9. So the 9 and the 9 cancel, and we get 3 over 9. But here we realize that 3 over 9, well, the 3 is 3, and 9 is 3 times 3. So 3 and a 3 cancel out, and we get 1 over 3. So if something's cancelled, that means there's 1, because 3, of course, is actually really 3 times 1, isn't it? So yeah, there you go. There's simplifying fractions and equivalent fractions. Okay, let's do perhaps one more example with algebra this time. Suppose we have 8x plus 2 over 4. Okay, so we're going to follow the same sort of procedure. First, we're going to factorize both the numerator and the denominator. So to factorize the numerator, we know we've got a factor of 2 here. 2 goes into 8x 4x times, and 2 goes into 2 1 time. And the bottom 4 is 2 times 2, so we can cancel these two 2's, they make 1, and we get 4x plus 1 over 2. There you go. So that we have simplified this original fraction. Okay, now we're on to part 2. Part 2 is adding and subtracting. Adding or taking away. Okay. Now the key here is that the denominator must be the same. Okay, the denominator must be the same. Let's do a basic example. 2 on 5 plus 1 on 5. Okay, we notice that the denominators are the same. They're both 5. So our answer also is going to have a denominator of 5. And now we can just add our numerators. 2 and 1 is 3. So our answer is 3 on 5. Okay, that's one example. Let's do another example. We have 2 on 5, but this time adding a half. Now our denominator, 5 and 2, they're not the same. So what I've got to do is do something to them so that they become the same. So if you're unsure of what that could, so you've got to basically make these into equivalent fractions so that the denominator is the same. So I want my denominator here to be, the simplest one is 10. So let's try 10, because we know that 5 is divisible by 10 and 2 is also divisible by 10. So to make the 5 down the bottom a 10, so to make the 5 a 10, we know that we need to multiply it by 2. So we know that we can multiply stuff by 1, so we need to multiply it by 2 on 2 to get this part here. And then for this one, a half. To get the denominator to be 10, we need to multiply that 2 by 5. Now because we're only allowed to multiply stuff by 1, this must be 5 on 5. So now we have 2 times 2 is 4 on 10, plus 5 times 1 is 5 on 10. So by the way, this whole step here, once you get good at this, you'll be able to skip that step. Okay. Now the denominator is the same, it's both 10, and 4 plus 5 is 9. So our answer is 9 on 10 for that. So a few things to highlight here, we've multiplied by 1, so we're allowed to do it. Here we've multiplied by 1, we're allowed to do that. And the whole point was to get the bottom bit to be the same. Okay, we wanted the bottom bit to be the same. So that's why we did that. As like a little side note, perhaps we didn't think of 10. Perhaps instead we thought of 20. because we know that 20 divided by 5 is a whole number and 20 divided by 2 is a whole number. So we could have chose 20, but here we'd have to get 20 on the bottom, we'd have to be multiplying by 4 on 4. And to get 20 on the bottom for this, it'd be 10 on 10. And that'd be then 2 times 4 is 8 on 20 plus 10 on 20, which equals 18 on 20. Then I factorize to simplify this. I factorize it. 18 is 2 times 9. 20 is 2 times 10. I can cancel these bits and get 9 on 10 again, which is, of course, the same as our answer the other way. So I just want to highlight that you don't need to choose the simplest thing on the denominator. It just needs to be the same. If you choose one that's not the simplest, you can always simplify later, and that's totally fine. Now, taking away is exactly the same. Like if this addition sign had have just been a minus sign all along, if it had been a minus sign all along, then this would have just been a minus sign, that would have been a minus sign, it would have been 4, take away 5, which would have been minus 1. Okay, so there's no change to our procedure, it's just a minus instead of a plus. Okay, let's do one more example, a more difficult one. So 2x plus 1 over 5 minus 3x plus 2 over 6. Okay, our denominator is not the same, so we need to make it something that's the same. Now I'm going to choose 30 because 30 can be divided by 5 and it can be divided by 6. So you've probably seen that a way to, if you're in any doubt, just multiply 5 and 6 together and you'll get a good thing to have as your denominator. Okay, so some people call this sort of cross multiplying, but I want to show you why that method works. So we want to get 30 on the bottom. So to get 30 on the bottom for this one, we need to multiply by 6. So 2x plus 1 over 5. So we need to multiply that by 6 on 6 to get a 30 here. 3x plus 2, 6. Now to get 30 here, we need to multiply the denominator by 5. So it must be 5 on 5 because we have to multiply by 1. So now on this side, we now have 2x plus 1 all times by 6. So that gives 12x plus 6 on the top and 30 down the bottom. Now this one, take away. Now similar thing, 5 times everything here, so 5 times both bits will give us 15x plus 10 on 30. Okay, now the minus applies to the whole thing at the top. Just want to make that very clear. So we've got 12x minus 15x, so that's minus 3x. And we've got 6 minus 10, so that is minus 4 and over 30. So some people, this stage that is perfect, that's the answer. But if you want to, you can take the minus sign out as a factor if you want to. So that is also correct. Okay, if you want to. So that is also correct. There are 2 different ways of writing the exact same answer. So there we go. There's taking away fractions. Yeah, leave that there. Alright, third thing we want to do is to multiply and divide. Okay, multiplying and dividing fractions. Alright, now to multiply fractions, we've actually sort of been using this knowledge to do lots of the other ones. So in hindsight, I probably should have put multiplying first, but it's too late now. So multiplying, the key is So we're going to start just by doing multiplying, by the way. So the key is you multiply the top and you multiply the bottom. So let's just do this using examples. 2 on 5 multiplied by 3 on 7. Now, for multiplying, it doesn't matter what the denominators are or the numerators. So you do the numerators first, 2 times 3, and then the denominators, 5 times 7. So the answer is 2 times 3 is 6 over 35. So there we go. So multiplying is quite straightforward. Let's do one more example. 9 on 2 times 4 on 3 gives us 9 times 4 is 36 on 6. Now you notice that we can simplify this. That's 6 times 6 on 6 gives 36 is 6 times 6, and we're left with 6. Now there's a quicker way to do that if you want to. You can factorize first if you want to. So you can go, well, 9, that's just 3 times 3 on 2. Multiplying by 4, that is 2 times 2 on 3. So overall we've got a 3 times 3 times 2 times 2 on 2 times 3. And we've got, get rid of one of those 3's, get rid of these 2's. So we've got 3 times 2, which is 6. Now with this method, you can sort of do a lot of that in your head once you get a lot of practice. Okay, so there's multiplying fractions. It's super easy and quite quick to do. And because of how easy it is to multiply fractions, that's one of the reasons why fractions are better than decimals. Okay, on to dividing. Now dividing is a bit of a nuisance for lots of people. So if you have 2 on 3 divided by, let's do a whole bunch of different cases. Let's say divided by 5 on 6. Okay. Now, with dividing, sort of the key thing to remember is flip and multiply. Okay, flip and multiply is the thing. So 2 on 3 divided by how many 5 on 6's? The method to use is 2 on 3. So multiply, but flip this second one. So 6 on 5. Then it becomes fairly straightforward. We've got 2 times 6, 12, 3 5's, 15. Now to simplify it, I can factorize that into 3 times 4, 3 times 5. These cancel, giving me 4 on 5. Okay, so that is dividing fractions. Now, sort of let's think about sort of the reason for this, if you like. So this part is not strictly 100% necessary, but let's think about it. Let's suppose for a moment that we just had 2 divided by 5. Okay. Now what a divided by symbol really means is actually doing a fraction. Okay, so 2 divided by 5 can also be expressed as 2 over 5. Now that's where this divide by symbol comes from. Do you see that it's just a fraction with a dot here where the 2 goes and a dot here where the 5 goes? And that's where this whole symbol comes from. Division actually just means fractions. So you can write it like this. So now let's think about something a little trickier. Alright, now let's do another one. So let's say we've got a third divided by a sixth. Okay, well, it's a similar sort of thing. So let's set up our master fraction. And then we've got a third at the top and a sixth at the bottom. So here we've got like a fraction within a fraction, also known as fractionception. Now, the way I like to sort of think about this is like what ends up being at the top of the master fraction, what ends up being at the bottom of the master fraction. Well, Well, here we've got so at the top, whatever is on your numerator sort of stays in the same place, and the other one swaps places. Okay, so, oops. So set up our master fraction again. That's supposed to be an equal sign, by the way. So 1's in the numerator position, so it stays where it is. 1. 3 is the denominator, so it swaps sides of the master fraction, or it sort of falls down below. So the 3 is down there. Now, similar to this one, there's a 1 here in the numerator position, so it stays where it is. There's a 1. So we've got 3 times 1 there now. And the 6 is the denominator, so it will swap sides. Okay, so a third divided by a sixth is going to be 1 times 6 over 3 times 1, which is 6 over 3, which is 2. Okay, so they're saying 2/6 makes a third, which makes sense. So if we sort of combine these two things now to do our original example here of 2 on 3 divided by 5 on 6. Now we already know our answer is going to end up being 4 on 5, which is the same as 12 on 15. But anyway, let's give it a go. So we'll set up our master fraction. I'll do it down here. So I've got 2 on 3 divided by 5 on 6. So the 2 stays where it is, 3 drops below. 5 stays where it is, and 6 swaps. Okay, so here we've got now 2 times 6, 12, 3 times 5, 15. So that's what we had before, 12 over 15, and we can simplify that to 4 on 5. 4 on 5. So there we go, there's dividing fractions. So if you don't fully understand what I'm doing here with the master fractions, just remember, multiply instead of divide and flip. But I much prefer this this method here with the master fractions. I think it makes a whole bunch more sense. So there you go. I hope you've learned a little bit more about fractions in this video, and are able to manipulate them a little bit more confidently. And more than that, I hope you understand why all of the different things in fractions sort of have to be that way. Alright, that's it for this methods basic video. See you later.